Welcome. In this video I will solve question number 1.123 from the problems in general physics by IRODOV. Let's look at the problem. The problem says that two bars of masses m1 and m2 connected by a non-deformed light spring rest on a horizontal plane. The coefficient of friction between the bars and the surface is equal to k. One minimum constant force has to be applied in the horizontal direction to the bar of mass m1 in order to shift the other bar. Let's try to solve it. So according to the equation, some force, horizontal force F is applied on the bar of mass m1. We have to calculate the minimum force for which the bar of mass m2 moves. So the forces acting on, the horizontal forces acting on the bar of mass m2 are frictional force and the spring force. The spring force will be k dash x. K dash is the spring constant, and x is the maximum elongation or the maximum compression of the spring. And in the opposite direction, the direction opposite to the direction of the spring force, there will be the frictional force. So the body will start moving when the spring force and the frictional force are exactly equal. So this is a constant, and what decides the spring force is the maximum elongation or the maximum compression of the spring. So we will have to find x such that it is equal to m2g k divided by k dash. When the elongation is equal to this term, the body of mass m2 will start moving. So now we have to consider the motion of the body m1. So let's consider what kind of a motion it executes when some force F is applied to this one. So like the forces acting on the body m2 is the external force. In the opposite direction there will be frictional force and the spring force. So once some external force is applied here, it will execute simple harmonic motion. So the spring will be elongated at some moment, and some other moment it will be compressed. So when the spring is elongated to the maximum extent, or it is compressed to the maximum extent, the energy is stored as the spring energy, that is k dash x square. So this x maximum, that is the maximum elongation or compression, is equal to this x, because for maximum x the spring constant spring force will be maximum. So when the total total energy is stored as the spring energy, the x is maximum, hence the spring force will be maximum. So our task is to find x, maximum x, when the total energy is stored in the spring. So writing the energy equation, work done by the external force will be kx. A part of it will be dissipated as frictional force, frictional energy, maximum. So the work done by the external force is equal to the work done by friction and work done by the spring, that is the energy stored in the spring square. Therefore F will be equal to m1gk plus half kx max. So now substituting the value of x from this equation, this is k dash, this is spring constant, m1gk plus half k dash m2gk divided by k dash. So this is the expression for minimum force for which the mass m2 starts moving when the force is applied horizontally to the bar of mass m1. Thank you for watching and follow my channel for more solution to the problems in general physics by IRODOV. Thank you.